Imagine becoming less aggressive because of a chemical signal you cannot consciously smell.
That sounds like a hidden calming scent. Is that what the researchers found?
Not exactly. The signal came from human emotional tears, but participants did not consciously perceive the tears as having an odor.
So tears might affect another person even when that person does not notice any smell?
Exactly. We usually think of tears as visual communication. Someone cries, we see it, and our response may change.
But tears are also a chemical substance.
Right. Rodent tears already provide an important clue because they contain social chemical signals with several effects, including reducing male aggression.
And previous human research found something related?
Yes. Women's emotional tears had been shown to contain a chemical signal that lowers testosterone in men.
Since reduced testosterone is associated with reduced aggression, researchers could ask whether tears also change aggressive behavior.
That was the central hypothesis.
What paper tested it?
The paper is titled, "A Chemical Signal in Human Female Tears Lowers Aggression in Males."
So they were looking beyond what people consciously see or smell.
Exactly. They examined aggressive behavior, human olfactory receptors, and brain systems related to olfaction and aggression.
That makes the main question surprisingly simple.
Yes. Can human tears carry an invisible chemical message that changes aggression? The researchers first had to separate an interesting biological clue from actual evidence about behavior.
Meaning that lower testosterone does not automatically prove lower aggression.
Correct. Hormones, brain activity, and behavior can be related, but they are different measurements. Aggression had to be tested directly.
They also had to avoid confusing chemistry with the emotional effect of seeing someone cry.
Exactly. If you watch someone crying, facial expression, empathy, social expectations, and the situation itself could all influence your response.
So simply showing participants a crying person would not isolate a chemical signal.
Right. The researchers instead focused on exposure to tears through sniffing.
And the lack of a consciously perceived odor matters here.
Very much. We often assume smell only affects us when we can clearly identify an odor. But biological detection and conscious smell perception are not necessarily identical.
So the olfactory system could respond even if someone says, "I do not smell anything unusual."
Exactly. Think of a background signal reaching a device without a large notification appearing on the screen.
Then, the researchers needed evidence at more than one level.
Yes, they asked whether tears changed aggressive behavior, whether human olfactory receptors responded to tears, and whether olfactory and aggression-related brain systems changed together.
If those different measurements agree, the interpretation becomes stronger.
That was the study's basic logic. For behavior, the researchers used a standard experimental paradigm for measuring aggression and compared men's responses after exposure to emotional tears with a control condition.
The participants sniffed the samples instead of watching someone cry.
Right. That removed the obvious visual social message of tears from the comparison.
And because the tears had no consciously perceived odor, participants were not simply reacting to a recognizable smell.
Exactly. The experiment could therefore test whether exposure to tears changed aggression under controlled conditions.
Then, the researchers examined the sensory side of the hypothesis.
They applied the tears to 62 human olfactory receptors in vitro.
Why test receptors separately?
Because if olfaction is part of the proposed pathway, it helps to show that human olfactory receptors can directly respond to the tear stimulus.
And they looked for dose-dependent responses.
Yes, a dose-dependent pattern means the receptor response changes systematically with the amount of stimulus, supporting genuine detection rather than a random fluctuation.
Then they moved to brain imaging.
They repeated the behavioral experiment during functional brain imaging.
So they could examine aggression-related neural activity during tear exposure.
Exactly. They also examined functional connectivity between neural substrates involved in olfaction and aggression.
Each method therefore answered a different part of the same question.
Yes, behavior measured aggression, receptor testing examined peripheral detection, and imaging examined the central neural response. The behavioral result was striking. Sniffing emotional tears reduced male aggression by 43.7% in the experimental paradigm.
That number sounds dramatic, but it needs careful interpretation.
Absolutely. It does not mean every man becomes 43.7% less aggressive whenever a woman cries. It describes the reduction measured in this specific experimental comparison.
What did the receptor tests show?
Of the 62 human olfactory receptors tested in vitro, 4 responded to the tears in a dose-dependent manner.
So parts of the human olfactory system could detect something in the tear stimulus.
Yes, the brain imaging results then added another layer.
What changed in the brain?
Sniffing tears increased functional connectivity between neural substrates involved in olfaction and those involved in aggression.
And aggression-related activity itself decreased?
Yes, the researchers reported lower overall neural activity in the aggression-related regions.
So several measurements point in the same direction.
Exactly. Olfactory receptors responded. Olfactory and aggression-related brain systems became more functionally connected. Aggression-related neural activity decreased, and aggressive behavior decreased.
That gives the behavioral finding a biological context.
Right. The researchers concluded that a tear-bound chemical signal lowers male aggression and likely relies on overlap between brain systems involved in olfaction and aggression.
And that resembles effects already observed in rodents.
Yes, the authors interpret the finding as part of a broader mammalian pattern. The biggest takeaway is that human crying may communicate through channels we do not consciously notice.
We immediately recognize the visible signals: tears, facial expression, voice, and social context.
But this study suggests that tears can also carry a chemical signal associated with reduced male aggression without producing a consciously perceived odor.
So, biologically meaningful information can pass between people without feeling like an obvious message.
Exactly. That challenges the idea that human communication consists only of what we intentionally say, visibly show, or consciously smell.
But this result could easily be turned into misleading relationship advice.
Yes, it would be wrong to claim that crying is a reliable way to calm an aggressive person. The finding comes from controlled experimental conditions and does not establish a strategy for managing dangerous situations or real-world conflict.
So, the practical value is mainly a new way of thinking about social biology.
Exactly. Human interactions may be shaped partly by chemical signals operating below conscious awareness.
And the authors propose something broader about tears across mammals.
They suggest that tears may function as a mammalian mechanism, providing a kind of chemical protection against aggression.
That makes tears more than simple emotional byproducts.
Right. In this study, exposure to tears was linked with measurable responses at the receptor, brain, and behavioral levels.
So, a visible sign of vulnerability may also carry an invisible biological signal.
And that is the central perspective shift. People may influence one another through chemical information that neither person consciously recognizes.